So our first airplane question here. It says a plane is steering on a heading of 225 degrees at an airspeed of 340 kilometers per hour. If the wind is from the east at 91 kilometers per hour, find the velocity of the plane. Okay? So again, this is kind of like this water question. We've got the plane's velocity, which is what the plane is trying to do. We call this the airspeed or the air velocity. Okay? We've got wind factored in here, so we usually call this the wind speed or the wind velocity. And what we want to find is the resultant velocity of the plane, which is the vector sum of those two. So the final velocity of the plane is usually what we call the ground speed, because it's this velocity of the plane relative to the ground. And it's the vector sum of the airspeed, which we call A, and the wind speed, which we call wind. Okay? So the ground speed is the resultant. The airspeed is what the plane is trying to do. And then, of course, W is the wind pushing it in some direction. Okay. So to get the resultant vector, or the ground speed, we have to do the vector sum of the airspeed and the wind speed. Now, what I usually do in these kinds of questions is, kind of like the force questions, I sort of make two diagrams. The first one here, I just try to visualize what the individual vectors look like. So we are told, let's see, a plane is steering on a heading of 225 degrees with an airspeed of 340 kilometers. These two pieces of information give us our air velocity. Okay? This is what the plane is trying to do. So this is vector A right here. Now, a heading of 225 degrees means, well, headings are always measured from north, from due north, and they're measured in the clockwise direction. So, with these little axes here, if this is north up here towards the top, I want to go 225 degrees in a clockwise direction. So that's going to bring me down here like this. Okay. 225 degrees. Okay. This thing has a magnitude of 340. And because I know from north to south is going to be 180 degrees, I know that this angle between my vector and due south is going to be 45 degrees. Okay, that's going to be helpful. Now, we're also given information about the wind here. Okay, so we'll do our wind vector in this second little axis here. The wind is from the east at 91 kilometers per hour. So if this is east over here, the wind is not blowing pointing towards east, it's blowing pointing away from east. So my wind vector is going to be like that, pointing towards the west because it's coming from the east. And this has magnitude of 91. Okay. What are we trying to find? We're trying to find the ground speed. The ground velocity is going to be the vector sum of A and W. So the vector sum of my airspeed and my wind speed here. So let's draw the diagram where we put these two things together. We've got our wind speed like this, 91, and I'm drawing that horizontal because it's coming from straight east. My ground speed, my airspeed is 340, okay, and it's coming down like this. So I should say that this is W and this is A. And my ground speed here, G, is going to be the vector sum of these two. So I've placed them tip to tail. I start at the tail of one, I go to the tip of the other. And that is going to be G, like that. So now we have to put in our angle information. So what do we know here? Again, I'm going to take one of my little coordinate axes there, and I'm going to put it right on the tip, on the tail of vector A. Because I know that when I'm looking at vector A here, the angle between the tail of that vector and the horizontal is 45 degrees. So I know that right in here, that has to be 45 degrees. How does this help me? Well, if I bring down another one of these, and I put it down here, I know that this angle right up here has to be 45 degrees as well. And if I put another one over here, does that help me at all? I don't think it does. Okay. But this is actually enough to do the question here, because I know that because W here is coming from due east here, that there's going to be a 90-degree angle right in here. So this angle in between W and A, this whole angle from here to here, is going to be 90 plus 45. I'll just do that calculation in blue here. 90 degrees plus 45 degrees is 135 degrees. So now I know magnitude of A, 340, magnitude of W, 91, so I know the lengths of two sides of my triangles. I know the angle in between them, so I can figure out the magnitude of G, the length of the side opposite them, using cosine law. Magnitude of G squared is going to be 91 squared plus 340 squared minus 2 times 91 times 340 times the cosine of the angle between them, which is 135 degrees. That goes into our calculator. Work it all out. We take the square root and we get 409.43. So that's our magnitude. We also need the direction of that vector G. So we want to find an angle inside the triangle close to the tail of vector G. So we want to find that angle right in there, angle theta. And again, I'm going to use cosine law here to find the size of that angle. So the cosine of theta is going to be, let's see, we need the sides, the length of the sides on either side of that angle there. So that's going to be, what is that going to be? That's going to be, right, 91 squared plus 409.43 squared minus the opposite side, which is 340 squared, all divided by 2 times 91 times 409.43 squared. And we're going to punch this into our calculator, and we're going to work out what theta is. So when we do this calculation, this shouldn't be a 2, because that shouldn't be squared. Sorry about that. We end up with 35.96 degrees, so we'll just call that 36 degrees. That's the angle theta there. Now, that's not our the final answer that we want for our direction. Because in the question originally we were given a bearing, or an angle measured from north, clockwise from north, we want to give the same thing in our answer. So the bearing for this ground speed is going to be this angle all the way around here like this, measured from due north. but we know that because what we have here is 36 degrees, let's see, we can work out what that is. 90 minus 36 is going to be, wait, what is 90 minus 36? 60, 54 degrees. So this angle right in here is 54 degrees, and then we just add 180 to it, and that'll give us our bearing. So 134 degrees, sorry, 234 degrees is our bearing. Okay? So now we can put our magnitude and our direction information together. So we can say the plane's velocity is 409.43 kilometers per hour. And we can just put our bearing here in for our directions, 234 degrees. Okay. And when you see an angle, like a three-digit angle, like that for your direction, you just sort of assume that that is being given to you as a bearing, measured clockwise from north. Okay. And that's what we were asked to find. So we are done.